Hi, this is Kevin Trainer, and this is the tutorial for the exercises associated with the Zelle Python textbook, second edition, Chapter 5. Chapter 5 is called Sequences, Strings, Lists, and Files. And what we've assigned this time are exercises 3, 4, 9, 13, and 14. And I'm trying to do this a little differently this time. I recorded a lecture last night which ran way too long. And so I'm trying to speed up things a little bit. I'm also trying to evolve these tutorials as we go through the course to expect a little bit more from you. Okay, so that you don't get too reliant on these tutorials. So what I've tried to do is to take each of the problems that we're doing, each of the exercises, and to boil it down to a description of what kind of problem it is. In a sense, it's kind of a shorthand for the pattern of the solution. Okay. And so that's the first thing I'm going to say. And then I'm going to say, okay, given that pattern for the solution, here's the one that I'm going to do. Well, it's going to be different from the one that's in the book for you. Okay. In some cases, 2 or 3 of the exercises are going to have the same pattern. Okay, in which case I'm only going to do one tutorial demo. In this case, it's exercises 4 and 9. Really use the same pattern. Okay. The other thing I'm going to do is I'm going to pause before I tell you what the pattern is to see if you can come up with it yourself. Okay. Then I'll announce the pattern and off we go. So your first one is exercise 3. And in exercise 3, if I can find the right page here, excuse me, a certain computer science professor gives 100-point exams. There's a certain grading scale, fairly standard, A, B, C, D, and F. And what they want to do is have you write a program where it prompts you for the grade, and then you give back the it prompts you for the number grade, and then the program calculates and gives back the letter grade. Okay, so think about the way that you would solve that problem, and we'll take a pause here to see what you think a kind of easy way to do that would be. And now we'll come back, and I'm going to say what the author of our textbook would really like you to try out is, let's get a little size on our text here. I also started to think that perhaps our text was a little bit hard to read. So let's do that. Our text is a little bigger now, huh? So here's the skill that I see. Create a crude lookup table using a character string. You see, we did that within the chapter where we did the months, okay? Now this is kind of a crude thing to do, and this is the last time I'd like to see you do it, but I'd like to see you master that kind of skill, okay? So you create a crude lookup table using just a single character string. You prompt the user for input so that you can figure which of the values you want to retrieve. Then you look up the value and you print what you get. Okay, that's what number 3 is all about. So what could we do? I'm going to do a really simple one where I create a table of seasons. I was thinking of the semesters, but there are places where they have a winter, spring, summer, and fall semester. Probably people who are on quarters would do that. But we're just going to call them the seasons. We've got they're associated with 1, 2, 3, 4. So we're going to prompt for an input, 1 or 2 or 3 or 4, and we're going to look up the season. We're going to print it. Okay? So let's get started. So first of all, I'm going to want a main. I'm going to skip my 2 lines, and I'm going to say def main. Okay, and I'm going to have a bunch of code here. And then eventually, I'm going to have my call to main. So that's pretty much my shell for program. Okay. And I think it's thinking that it wants my code up here. So let's just put a print up here and see if that goes away. Print. Yeah. As soon as I say I want to print something, I'm okay. Okay, so what am I going to do? Well, I'm not going to work so much with the pseudocode this time because this is pretty straightforward. Okay, so what we've been doing is printing out a polite message, haven't we? So let's do that. Print. So, you know what? I'm going to put 3 prints up here. Print, print, print. So, one of the things I like to do when I see something that I can copy paste is to do that. So, I'm just going to take my skill information right here, copy it, and prompt user for input. Lookup value and print. Okay. Now, do you have to put all this? No, I just wanted something to print up here. Because we've been doing that. It's kind of the pattern that we've been following. I'm going to clean it up so it looks like I am polite enough to use caps. So I've got that. All right. So pretty good stuff, right? And probably before I go prompting for my input, oh, I see I have an extra L. Probably before I go prompting for my input, I probably want to have a blank line on the console. Now, there's 2 ways I can get a blank line, okay? One way is just to put a new line character sequence down, \n. Okay, so that's going to print an extra line. And a lot of people would do that. Certain other people like me would say, you know, maybe that's not going to look so obvious to people, so let's just put a print there. A print, I think we should really put empty parens, okay? And that's probably going to get us a blank line. All right, I've got all that done. Let's give it a test. So, give it a test. Looks fine by me. All right. Okay. So, I guess I'm going to have to make my crude lookup table. All right. Okay. So, let's assign some character value to a variable. So we're going to call this seasons. Okay, equals. And if you remember, when you're kludging together a crude lookup table like this in a single string, the trick is that they all have to be the same length. So let's look. Winter, spring, summer, fall. Fall's the shortest. It's 4 long. Okay, so let's say 4 for each. So are they going to be caps, mixed case, lowercase? Let's put them into mixed case. W and TR. Okay, and now the next one is going to be SPRG. and the next one is going to be SUMR. And the last one is going to be FALL. Okay, those are all 4 characters, and we ought to be able to come up with a way to make that happen. Okay, so let's just simply print that for now for testing. Okay, so let's run this, and we see our work right there. Okay, well, that was a piece of test code that I don't think I'm going to need, so I'm just going to get rid of it. And okay, we've built the table. Now, what's the first thing we have to do? Well, we need to prompt the user. Okay, so and what are we going to get back? Well, we're going to get back a season number. So I'm usually pretty literal with the way I name my variables. A little bit of typing I don't care about. Okay, I would really like to see you to be more verbose rather than less in choosing your variable names. So season number equals so I'm going to say input please enter the season number colon space. Okay, so that's nice. It's polite and it's explicit. Okay, now I have to turn it into a number. Am I going to use eval? Well, I could. Okay, but then they could give me a season number with a fractional part. I don't want that. I want to make sure that what I get out of here is an int. So I'm going to wrap this in an int. Okay, which is going to convert the string that we get back from that prompt, from that input, to an int. Or if they give us something that's not a proper int, we're going to blow up, which for our purposes right now is just fine. All right, let's give it a test. Please enter the season number 4. Okay. That seemed to work just fine. Let's run it again. Please enter the season number 2.5. That should blow up. Did. Okay. That's just fine. So we're fine. We prompted for that. Now we have to figure out how we can figure out the number of the character string. Remember, we have to come up with the starting index because we're going to slice it. Okay, so we're going to have to come up with the slice expression. Okay, let's try to come up with a slice expression for each one and see how they work. Well, we'll pick 2. So winter, say we want to print seasons, square brackets, and we want to start with 0 and colon, and we want to go through 3. All right, so let's give that a run. So we can put anything in here we want, and it says, oh, interestingly, I made the mistake of doing exactly what I wanted. Remember, this second index is the index of the first part we don't want. Gosh, that's fun. All right, let's try that. Let's try it the right way. All right, so just give it some input. Winter. Well, that's looking good. So that's a way to do it. 0, 4. Okay. And then let's see, let's do another one. Let's do the last one. Okay. Copy that. We'll do them both. So the last one is what? Fall. And so we want it to be So it's the fourth one. So 4 times 4 is 4 times 3 is 12, so it should be 13, 14, 15, and 16. But we start counting with 0, so this is going to be number 12. Okay. And I'd want to say 12 through... oh, this is 4 characters long. I'm sorry, that's why my 3 didn't work. I'm sorry, it's not the first one that we don't want. Gosh, I need a little more iced tea. So 12 through 16. It's not the first one that we don't want. My bad, I'm sorry. So let's save this and give it a run. Okay, and we'll just give this a number. Oh, so we got both winter and fall. So if we look at this formula, okay, what we want to do is we want to have a formula that is going to translate from season number to the first index that we want. Okay, so let's say season start index is equal to, okay, so we started with 0, so when we are looking for season 1, we want to get 0, so I'm going to say that we probably want an expression like season number -1. Yeah, I think that's right. Okay. And then, so that's going to work for this one here. Okay. Now, I think we probably want season number times 4 minus 1. Season number times 4 times 4 minus 1. Okay, so here's what we're going to do. We're going to change one of these. Season number times 4 minus 1. Oh, we don't need that closing brace, do we? No, we don't. All right. So, one time. No, that's not going to work. Okay. I'm going to take a pause, and I'm going to think about this. I'll be right back. Hey, I'm back. And you know what? I started out the right way, but I lost my confidence. So how did I get my confidence back? Well, I just went back to the chapter where we had done the month thing, and I looked at the program code that we have for month.py, and on page 128, I see that we're calculating the position as n minus 1 times 3. And that's the way I started, but I lost my confidence there. I outthought myself. So is it times 3 for us? Well, no, it's times 4 for us. Okay. All right, so I think that's going to look better. So, so what do we want to do? Well, we want to print seasons, and we want to put expressions in those slots. So the first one is going to be season start index. And here we're going to autocomplete with a double click. And I'm going to say season start index plus 4. Okay, and could you put parens around season start index plus 4? When I'm being really compulsive, I would, but I wouldn't. I'm not going to recommend it now. So, okay, let's actually run a test of this again. Put in 1. Okay, I didn't do it the right way. Put in 1 here. And, you know, I found out I can also change the size of this. Okay, so 1 was winter, and I still did the winter and the fall. So I got what I wanted with value 1. Let's just keep testing, right? So let's go again. I don't know. Oh, I had typed accidentally. I don't know if you do this, but sometimes when I think I'm typing in my console, I'm corrupting my code. And that's what I did there. So it worked for 1. Let's see 2. Spring. That's good. Let's see 3. No, that's 2 again. 3. And every time I do this, I have to make it bigger, which I don't particularly like, but they gave it to us for free. Summer. So winter, spring, summer. Okay, that's good. And let's run it again and put in season number 4. Fall. Okay, so that looks good. Okay. Now, before we start to do the boundary testing, I'd like to do 0 and 5, but let's pretty it up first. Okay. So I would like to say something like this. So I'm thinking that I would like to have a pretty line of output. Where I'd like to print this, but I'd also like to say the, season 1 is name, okay? But I just don't want all that code in my print line. So how can I avoid that? Well, anytime I want to just keep a character value, okay, I can just do this. I can say, season name equals, okay, and I had parens around that because those had been the parameters to a function call, but so I don't really need to have parens around that. I can leave them there, but I'm going to take them out. Okay, and now what I'm going to say is I'm going to say print season number is and then let's put out season name. And let's say season name, and we would also like to get a period right at the end. So we don't want to say comma and then a string that's a period because we'll get a space before it. But we could just say, we could concatenate a period with season name, and that's going to put the period right up against the season name. All right, let's look at that. Okay, so let's run number 4. Season number 4 is fall. That's good. Again, I'll make it a little bigger so you can see it. Okay. All right, so that's looking good. I've got that tested. I want to test the values that are going to be problematic. So let's try a season 0. 0 is input. Season, what did I get? I get season number 0 is blank. Okay, not really sure why that happened yet. Let's try 5. Season number 5 is blank. Okay, so one of the reasons that we're getting this, and I thought about it just since I said I don't really know why this is happening. We're using indexes that are essentially out of bounds, right? We're asking for things that aren't on the table, and with this slicing, if we ask for a slice that's not there, it's just going to give us nothing back. Okay, so apparently it's not blowing up. It's giving us nothing back. Well, that's okay. It's a pretty reasonable answer. Okay, so that's all right. So I'm thinking that's okay. And I'm just going to take this. Excuse me. I'm being called. Okay, so I've prettied up all this stuff. I kind of like it the way it is. I like my 2 blank lines before the main. I think I've done enough testing. I'm going to do my code inspect, see what it does. I want just the current file. If I've got 3 typos in my spelling. Oh, that's in line 15, I think. But that's okay. And let's see. White space before. Where's that? White space before the... Oh, it's interesting here on my index. It doesn't seem to like the white space that I placed before the colon in my slice expression. Let's see if that'll go away. So let's say reformat file. So let's test it again. Inspect the code. Do the custom again. It was okay. So oddly enough, it wants me to not have a white space before this, but to have I can have a white space after it. And okay, I'm going to honor that until I find out why they want that, because I'm not really used to doing that. But I'm also not used to doing this check. I just decided to master this feature. So I'm going to make it happy, and I'm going to leave it just like that. Okay, so that's it. It's all tested, it's all clean, and we're ready to move on to the next one. So the next one is question number 4. And let's just take a look about what question number 4 is about. So question number 4, an acronym is a word formed by taking the first letter of the words. So what we want to do is we want to prompt get one line of text in from the user, and then we want to create an acronym from the words and the phrase that we get from them. Okay, so we want to take the first letter and capitalize it in the acronym that we build, then we want to print out. Okay, so I think, again, this is a general kind of pattern, right? So I'd like you to think about what the pattern is, and I'll pause, and then we'll come back, and I'll tell you what I think the pattern is. Okay, we're back. So let me go to 4. And you know what? Turns out I think that 4 and 9 are the same. I had said that earlier. So let's take a look at this. So I'm getting my text to work out, right? I'm going to tell you. The word that I've been using here is pattern. We're looking for a pattern. The term software pattern has only been around since, well, probably the 1980s or the early 1990s. Okay, it really came out of object-oriented programming languages and the designs for them, but it's really borrowed from architecture, where there was a particular architect who said, you know, it doesn't make sense for each architect to think up the solution all by herself when we have in the profession 1 or 2 or 3 kind of standard ways that we solve this problem, and we should train new architects to recognize those ways. And so the architecture guy said each of these is a pattern. And that was really picked up in other disciplines, and it was picked up by the object-oriented software people. And there's a famous book by a group of people they call the Gang of Four, or GOF, Eric Gama et al., called Object-Oriented Design Patterns. And it was a really influential book, and I might mention a pattern or two when we get to the point where we're designing our own objects at the very end of the course. But one of the really nice things that Zelle does is that he takes this term and uses it more broadly and goes back to some patterns that people have been using in procedural code that a lot of these had not been pointed out, and they had not been called patterns. So this is I think the thing that Zelle does that I really like. So the pattern here that I see is this is a pattern where we take a single line of text, we split it into a list of strings, which is pretty easily done, and we process the list elements. After processing the list elements, we have some kind of result. Okay? So that's true for 4, it's true for 9, it's true for all kinds of problems. So what would be a good example of that we could do here? Well, how about the line of text is a phrase, okay? And instead of doing acronyms on something about like that, let's do it like this. Let's take the phrase, let's have it be all caps, let's turn it into all caps, and I'm sorry, let's take the phrase, turn it backwards, and print it in all caps. Okay? So if the phrase was how now brown cow, it would be cow brown now how, all in caps. Okay? And for right now, let's say we're not going to put a punctuation in. Sometimes when you're trying to reverse things, punctuation is kind of problematic. All right, so we want to treat them a word at a time. They'll be separated by spaces. All right, so let's get started here. Okay, let's create our main. I like to skip my 2 lines because I don't want my code analyzer to complain. Sorry, def main. And let's just put a print there so it's not going to complain when I come down here. Not going to complain when I come down here and just have a call to main. I try to keep the screen clean such that when a real error happens and it pops up and it gets underlined in red, it gets my attention easier. Okay, so I tend to appease this syntax checking in the editor, even if it's not something really big. So let's print some polite text. Okay, so what could that be? Let's say we want to print a character string, and we want to do that. I put that on 3 lines, so we'll put it on 3 lines. So copy paste, and code. Let's just take our skill description. Okay. All right. And what did I do? I prettied those up the last time, didn't I? So I'm going to pretty them up again. Don't they look pretty? All right, let's give it a test. Test early, test often. Okay, come down here. Those look great. Okay, so now we're going to prompt for a phrase. Okay, shouldn't be too hard to do. Let's come down here. Let's call it input phrase. Okay, so this is the phrase as we get it. And we're going to use the input method, and we're going to call let's say, please enter a phrase. Please enter a phrase. Put a space on the end. Okay. Okay. And let's just print it when we get it. I'm not going to keep this, but it's good for testing. So it doesn't like input phrase because I misspelled phrase up there. So I'm going to copy this name and paste it over the other. And now I don't have a mismatch. All right, let's give it a run. So let's do this. So let's just say how now, brown cow. How now, brown cow. That came out fine. Okay. Well, all right. So what's the first thing that we want to do? Well, we want to split that line of text into a list of strings. So how are we going to do that? Well, it's already separated by spaces, so it's really easy just to call split on it. So let's call this words. Okay. Equals input phrase and what do? Well, we're going to call split on it. We're going to call the split method of this input phrase object, and we don't have to pass in any parameter because we're taking the default. We're splitting it on space. Okay, and let's see what we get. Let's say for word in words, print word. Okay, so that should go through them. Sorry, or word in words. It's not working. Pause. Sometimes this editor and I don't get along because I just did a delete of the colon and I put the colon back in afterwards, and now it works. So perhaps I hadn't typed what I thought I typed, but I thought I had typed just what you see here now. So let's give it a run. And let's do 3 blind mice. 3 blind mice. Okay, so we've successfully split the phrase. Okay. And now we're going to want to do something with it. Now there's a lot of ways to print it backwards in all caps. Okay. Let's think about this. Now, one way is to go through all the work of trying to create another list that's in the opposite order. But what if we could process this list in another order? Okay. Well, how would we do that? Well, we could use another we could use a range expression. Okay, so we could maybe do this a little different. What if we said this? What if we said for word in range, okay, and what do we want to start with? Well, we want to start with the last one. Well, how can we figure out what the last one is? Well, we can find out what the length is. Okay? So, the last one is words.len. And that's -1. Okay? Because the length on these 4 words is going to be 4, but the last index that we want is 3. Okay. Now, then we want to go down to we want to go 3, 2, 1, 0. This is where I get a little bit weird with this. If we're to do the way it works the other way, I think we should say -1. That's the first one we don't want. So let's do this. We'll see. Okay, so let's give it a run. Three blind mice. Oh, good. So the first thing I find is that I can't find out the length of a list by using len. That only works with string. So how do we find out the length of a list? Well, we're going to go and look at the table of things that we can call on lists. Lists have method 2 and I shall return. Yes. Guess what? This is a really good situation. I'm glad I screwed this up. Okay. In Python, there are a number of features that are implemented as functions. They're built-in functions, right? And one of them is len for length, okay? So if this, what you're trying to do, uses a function feature, then you call the name of the function. You don't have to include the name of the package because it's one of the built-in ones, okay? And then you pass it the name of the list. So instead of words.len, which is the way we would say it if len was a method of every list, we say len paren words. So we use the standard len method and we pass it the words list, and it gives us the answers back. So len words. Okay. Oh, let's see that work. All right, coming down here, 3 blind mice. Well, it doesn't seem to have worked. Oh, I know why. Because we didn't say -1. Let's try that. Because we didn't say how are we going to do the stepping. I said I wanted to start at length -1. That's fine. Okay. I have a little bit of an inkling we may have to stop at 0 here. We'll see. And then how do we want the steps to go? We want to step down one at a time. Okay, let's give it a shot. 3 blind mice. Okay, and so what we got? We got 2, 1, 0. Oh, of course that's true. That's not what we want. We want words. Oh, so that's great. Look what we got. We got word is the name for the loop index. Okay, so what was the loop index each time through? 2, 1, 0. Just what I wanted. I used the wrong expression here. I want to get the element of the words list that is being pointed to like that. Okay, so I want to get the 2th, the 1th, the 0th. Let's give that a try. So give it a run. Okay. 3 blind mice. Well, doesn't that look good? Mice blind 3. Okay, so I'm processing them in the right order. So that sounds good. Alrighty, that sounds really good to me. So what could I do? Well, let's accumulate the output phrase in a list. Okay, so let's do this. Let's say that we want an output phrase. Okay. Let's do this. Instead of printing this, let's say output phrase in which one we have to do it 1, 2, 3. We have to count up, don't we? Probably we just want to add one to the list. So let's do that. So now here I am. I don't have the documentation now, but I think I'm going to be able to just append that word's word. So we're talking about output phrase, unresolved reference, isn't that a mess? Well, this isn't going to work at all. I'm going to have to stop this. Well, I'm back, and I got it to work. And again, a couple things working a little differently than I had expected. But so when we left here, we had a pretty good loop. Okay. We had come up with a for expression that walked down our list backwards. Okay, and it took a little bit of thinking because we had to take the length of the list words. We had to subtract one. That gives us the top index. Okay, and then we had to go down by one. And where did we want to stop? Well, you would think you want to stop at the 0th one, but the way that this range works is you actually give it the number of the first one that you don't want. So if the last one you want is 0 and you're going down, well, the first one that you don't want is -1. So that's how we got that, and we ran that and we got it. In fact, let's just take this code that we have here, okay, which I have since added, and hang on to it in my little parking lot over there. So we have these, and where we were last is we would say that we wanted to print print words sub, and that would be word subword. Okay, index word. So that's where we were, and we went down, we ran it, and we put in 3 blind mice, and we got back mice blind 3. Okay, in fact, let me take out this other line too, because we didn't have that there. We didn't have that yet either. Okay, so run it one more time to prove that I'm not cheating. 3 blind mice, and make it look a little bigger, mice blind 3. Okay, so there's a lot of things that we could do here. We could do string accumulation the way that I've already taught you. Okay, string accumulation the way I've already taught you. Well, we would come up with an accumulator string. We'd give it an initial value of, well, let's just do that. Let's come up with an accumulator string. Okay, and let's call it output phrase. We have an input phrase. Okay, and these accumulator strings, we always initialize them to being empty. And let's put that on its own line with some blank lines around it. Okay, And instead of printing this, okay, let's just add it on to the output phrase. Okay, so let's just say output phrase equals output phrase all right plus, and just take the character string that we just got. Okay? And then when we're done, let's say we're going to print the output phrase. All right? Let's do it. Print output phrase. Okay, let's see how that goes. Okay. 3 blind mice. Okay, well, what did we got? We got mice blind 3 all together. Can't quite see that, but now you can. Okay, well, that's not quite the accumulation that we wanted, right? We wanted to see what we wanted to see, right? Now, as we're doing this, we have the problem here. As we accumulate this, we have the problem that we want to separate the words with a space. Okay? Now, the problem that we have with that, trying to do this in the classic accumulator way that I'm talking about, is this. We want to put a space between, let's see, mice and blind and 3, but we don't want to put a space before mice or after 3, right? We just want to separate the internal words with spaces, okay? So the problem with the kind of setup that we have here is you don't know if you decided that you were going to always append a space to the front, then we'd have an extra space in the front. If you'd say we're always going to append a space in the back, so we could say something like this, plus space, okay? And we could run this. And do 3 blind mice again. And mice blind 3, that looks good. Well, that looks good, except that we're actually printing a space that we can't see. For instance, if we put, let's put underscores in here so you can see what we're really putting out. Well, three blind mice, we get mice blind 3. So we don't want that last character, right? Because if we really wanted to take that and we want to do something further with it, well, that's not going to make a lot of sense. So it's kind of cheating to do that. Well, there's another way to accumulate strings, and it turns out to be particularly efficient because, as I mentioned earlier in the week, every time we look like we're changing the value of a string, like we're doing here in this line 21, we're really not changing the value of the string. What we're doing is that we have an expression here that creates a new string, and this variable is being pointed to the new string. The old string, well, it goes away. We do this thing called garbage collection on it, and we'll talk about that before the course is over. But so if in fact we're trying to accumulate 3 words, well, then we create 4 successive strings, because we create the empty one, the one with one word, the one with two words, the one with three words, the one with four words. And that's a lot of object creation, and we generally feel that that's not as efficient as we would like it to be. So the way that real Python programmers accumulate strings like this is that they do it in lists. And then they join the members of the list with a join, which is a method that lists have. And it turns out that one of the options of the join is to say, what character would you like to put between the members of the list? And actually, join is not a method of the list. Join is a function. You'll see it in a minute. Okay. So, how are we going to do this? Well, let's do it. It's a little bit easier to do than you would think. So what we could do, so first of all, we need to construct a list in the opposite order. Well, how would we do that? Okay, let's do that. Well, first, we have to know that how do we add something to a list in a loop? We use a call to the list called append. Okay, I think I got rid of too much here. Yeah, So first, we need to create a list that is in the other order. So let's create an output phrase list. No, let's not call it output phrase list. Let's call it output list. So this is going to be in the other order than words. Okay? And we want to do two things. First of all, we want to create an empty one. How do you create an empty list? Well, you create a list with square brackets. An empty list is just square brackets. Nothing in it. Okay? And then how do you add something to a list? Well, you do it with a call to the append method for the list. Okay? So let's say output list append. Great. You give it the argument of what you want to append. And what do we want? Well, we want to pick from the words list. We want to use the index of word. Okay. That is it. Words, word. Okay. And then what we're going to do is we're just going to print output list. So let's review for a second what we did. We create an empty list that is going to be the words that we want in this proper reversed order. We have our loop that traverses the original order list, okay, but it does it from the back to the front. Well, as we're doing that, every time we encounter a word, we append it to the output list. So when we get done, the output list should be in the exact order that we want. That looks pretty good. So let's give that a test. So we're going to give that a test. And let's say 3 blind mice again. And what have we got? Well, this looks promising because we have a list, just like the input list. It's just in the opposite order. Wow, that's great. That's just what we want. Now, we've got a couple of problems with it. Problem one is, didn't we say we wanted them in uppercase? Yeah, we did. How are we going to do that? Well, we just have to find a string expression and shift it to uppercase. Would you agree? Okay. All right, because every string expression yields a string object. String objects have a method called upper, and they're going to give you a string object that's in uppercase. Okay, so when we append word, you know what? That's a string. Let's just call upper on it. UPPER, and there's no argument. Well, let's see that work. Let's give that a run. 3 blind mice. Mice blind 3. That looks good. Okay. Let's see if we can find an expression that's going to join together those parts and put in between them a space. Well, here's how we're going to do this. Let's let's not all do it in one line. Let's create the string, and then we'll print this string. So let's say we're going to print an output string. Okay, that's an output string. But we haven't created one yet, so let's create one. Let's say output string equals, okay, a character string with a space in it, join to self. Well, it said self. I don't think we really need to do that. I think that self was implied. So output list. I think that's what we need. Okay? So what's this saying? Well, it's saying to join the elements of the output list, to join those strings, and to fill in between them with whatever string I'm using to call join on. And then we're going to print output string. Let's see if that works for 3 blind mice. 3 blind mice. Mice blind 3. Ain't that exactly what we said we were going to do? It is. Okay. So let's pretty this up. Okay. We don't have any commented out code, so we're looking good here. We've got a lot of extra lines here before main. So we want 2 blank lines. That looks like what we have there. Okay. Let's give it a code inspect. See if there's something it doesn't like. Say this is sticky here. It's saying the current file. That's good. No suspicious code found. That's nice. It likes our code. That was down in the lower left. Okay, so now that I'm done with the code, let me test it one more time. Okay, so let's say the quick brown fox jumped over the lazy dog. So dog lazy, the over jump fox brown quick the. Just what we wanted. Now, it's a toy problem, right? Not a lot of times we get a call for exactly that stuff, but what we've done is we've done it if we go back to what the skill was that we're trying to do, we're going to split a single line of text into a list of strings, process a list of elements. In this case, we created a new list of strings in the opposite order and in uppercase, okay, and then we printed the result. Okay, we joined it to create the result, and then we printed it. Pretty nice. Now, a couple of things that we've shown here we haven't done before. This way of accumulating text in the output in a list, and only at the end joining it into a single string. This is much more efficient because every time we are doing something to the list, we're not creating a new list. But every time we did it the other way, where we were concatenating things onto the string, it looks in the code as though we're changing the value of a string. But because strings are immutable, we're not. In fact, what we're doing is we are creating a new string object. So this turns out to be a lot more efficient way to get the job done. I'm going to leave you with this and on to the next one. Bye-bye. Well, not completely bye-bye because I'm going to go to the next one. Okay, so let's look at number 13. Redo any of the previous programming problems to make them batch-oriented. Use text files for input and output. So the question already tells us what the pattern's going to be. It's going to use a batch processing pattern. Okay, and we talked about that earlier. So let's just take a look at the way I set up number 13. Okay. So how are we going to do? So here's the skill. Take an algorithm that processes one line of text input to create novel output, which is to say input, process, output. So we're somehow going to transform things. How did we just transform things in the last one? Well, you know, we printed the phrase backwards and in all caps, didn't we? Oh, yes, we did. Okay, so then how could we take a file of input and process it in a way that we could do this over and over again? So each thing that we just did, we're going to do it more than one time. For every input, we're going to do that and create an output. Okay, so what we really want to do is we want to wrap some kind of solution we have already in a batch pattern. So that's what we're going to do. All right, so let's get started. All right. So let's, the solution, the one that I'm going to do is print the phrase backwards and in all caps. It's the one that I just showed you. And I'm going to adapt that to batch. So I'm going to leave the code for the actual work. I'm going to leave that out for now. Okay, and I'm going to plug it into the pattern. So how does a pattern work? Well, let's see. We're going to need a main. All right. Always going to need a main. And let's just put a print here so that it's not upset that there's nothing in the main. And then let's have a call to main down at the bottom. And that looks good. Okay. So if you remember, what we want to do is print out this stuff up here. So I've got this on 2 lines up here. I've got the skill on 2 lines up here. So I'm going to copy this, and I'll copy the 2. Copy that. Paste it in with a Control V. Take my second one. Copy that. Paste that in with a Control V. And I only have to capitalize, let's see, take and then adapt. Didn't quite do the line breaks quite the same way. All right, we've already got something we can test. Give it a run. That looks nice. Very good. Okay, so let's do a little bit of kind of pseudocode that we could have for our batch pattern. Okay, so what are we going to put first? Well, let's put them into comments. Okay, well, that's not what I wanted. Must have hit the wrong control key. So, all right. So the first thing that we're going to do is prompt for names of input and output files. Right? That's what we did. Okay. Next thing we're going to do is we're going to open input and output files. Right? Then we're going to have our processing loop. And we're going to say for each input line, okay, that we're going to do something. So each input line we're going to round, we're going to do what we want. Okay, that sounds good. And then what else have we got? Well, then we've got, so we're going to process the loop, we're going to get it all done. You know what we want to do? We want to say that we're done. Okay. Sometimes I would call that cleanup. Okay. Let's just say print completion message. All right. How does that seem? All right, that sounds good. And then we're going to run it. All right. So let's get started. Okay, we don't need a lot of extra lines here. So let's see, this is part of main, so we probably want these to be indented. These are all in main. So these are comments for that. So prompt for names of input and output files. Okay. Okay, so in file, that's a pretty good name, equals input please enter file name. Let's say input file name. Okay, and give us a colon and a space, which we usually put here. All right, that looks good. And then let's clone that. Okay, because what we're going to say for the output file is pretty darn close. So we're going to call this out file. Okay, that's good. And say please enter the output file name. All right. Okay. And then let's just put a couple prints in for testing. We'll do this. So that's so what we want to call this in-file name. In-file name and out-file name. Okay, so this is not the file object. This is a character string that's going to hold it. And then let's just put in some test code. Print in-file name and then a comma and the out-file name. Okay, well that looks pretty good. Let's give that a test. So we're going to go down here. We're going to test. Alrighty. Okay. And you know what? Already I know that I want to have a blank line after the last of my description lines. So I'm going to do it the other way this time. I'm not going to put just a plain print there. I'm going to put a \n for a new line on the last of the lines, and that'll give me an extra line. So let's just look at that. Oh, that's just what I want. Okay. Okay, so enter an input file name, Joe input text, Mary output text, and let's see. Yeah, it looks like I got the strings in okay. That's fine. All right. So I'm going to get rid of that print because that was just for testing. I know I've got this in okay. Okay, so let's open the files. All right. So now we're going to say in file equals open in file name R for read, right? And that's clonable. So I'm going to copy paste. I'm going to call this one out file. Out file. Open. Out file name. And that one's going to be a write. Because on input we read, and on output we write. Okay? Alrighty. So then, what are we going to do? Well, let's print a completion message. Okay? The processing for the loop, well, I'm not sure how to do that yet. Well, I have my ideas, but so let's print a completion message because we know that's easy to do. Okay. Oh, you know what we didn't do? We didn't close the files. Okay. That's why this is probably a lot of times I would call this cleanup. Okay. We want to clean up our processing environment. Okay, so that includes closing files. So let's say we want to close in file, and we want to, oh, I'm sorry. It's really hard to remember what's a method and what's a function. Well, it's not that hard, but it's easy to get turned around. So it turns out that while open is a method that we call and we pass the file name to and we get back a file object, when we go to close it, well, we have a file object, so it just has a method. So we can say infile dot close. Call close on infile. And then we can say outfile dot close. So we've closed them, and then let's print our completion message. So print let's just say something generic. Processing complete. Okay, how's that look? Not bad. So we haven't done anything with the files, but let's see how we're going to do. So we're going to open files, close files, do the process incomplete. We don't do any work on it, but let's see if we can open them and close them and have our complete message work, all that. That's all stuff that needs to be tested. So let's give it a run. Give it a run. So, oh, now, here's my problem. My problem, well, let's just see. Let's call it myfile.text. Okay. Call it myoutfile.text. Is this going to work? Can I open myfile.text? Let's see. Kaboom! Why? No such file or directory, myfile.text. Yikes! Okay, we have to create one. How do we create it? Well, let's just create it like this. Let's go in, go up to the project, say we want a new file. Okay, call it, I'm going to call it tutorial. I'm just going to call it common phrases .text. Go. We're going to do that. Oh, txt. All right. When I do it, it opens a file for us. Well, that's good. So what did we have? 3 blind mice. How now, brown cow. Let's get these a little bigger so you can see them. How now, brown cow. We love Python. I am a data scientist. Oh, we don't want to, we're not capitalizing anything. Okay, and what's the next one? Librarians are the warriors of learning. Let's make a claim like that. And whatever we were going to say. Only a small fraction of this mess will end up in the archive. All right. So there's a bunch of phrases. Now, I want to point out, the question is, how many lines do we have here? Well, we've got 6 lines. It looks like there's a 7th that's blank. Okay? So if you want to have just 6 lines, you want to leave the cursor at the end of 6. That's fine. That's a 6-line file. This is a 7-line file that has an empty string in the 7th line. Okay? So be aware of the difference between those two. Okay, so we're going to save this. All right, and let's look. Let's go back to our program. And what did we call this? Common phrases. Now, commonphrases.txt is the name that we're going to use, and we can because it's in the same directory because the project is a directory. Okay? So when I run this again, and it says, I want the name of the input file, you want to put in common phrases.txt. Okay? And here we're going to say phrase output.txt. Okay, processing complete. Okay, now let's look at commonphrases.txt. Has it changed? Nope. Why? We didn't do anything but open it. Let's look for phrase output.txt. Oh, we have it. Why? Soon as we successfully open it, we have a file. There isn't anything in it. Look how there's no line 1 here. Okay? We have a cursor there, but there's no line 1. This is an empty file. Pretty cool, huh? All right. All right. So, how are we going to read this? Well, let's just try something like this. Let's go back to our program. Okay. And let's do a processing loop. Okay. Let's say something like this. Let's say for line in file, print line file equals out file. Okay, so every line that we can read from in file is going to go to out file. Okay, let's see how that. Now, do we do any processing? No, and we haven't done that conversion that we promised to do later. Okay, but pretty much this shell that we've created is the shell for a batch pattern solution. All right. Let's give it a shot. So we're going to run it. Okay. And let's call this common phrases.txt. And I'll make this a little bigger so you can see it. Common phrases.txt. And what did I call that one? Phrase output.txt. Phrase output.txt. Okay. And it took a little bit longer to get the processing complete because we did some work. So let's go look at those two files. Common phrases shouldn't have changed. We only opened it for input. Okay, so you can't really blow up anything in the input file. Phrase output, what's there? It was totally empty before. Look what we have. We have what we want here, okay, kind of. What's going wrong? Well, we're inserting a blank line. Why? Well, we're inserting a blank line because every time we do print, we put in a new line at the end. And there already was a new line at the end of that line because that's what we get in as we read each line. So we need to ignore the last character of our input line when we print it out. Well, that should be pretty easy to do. Let's go back and give it a try. So instead of line, let's use a substring expression, okay? And let's say that we want to start at the beginning, okay? And we want to end before we get to the last character, and the last character is -1. Remember, you can count from the back with negative numbers. So let's see that one run. All right, going to give that a print. All right. So let's say this is going to be common phrases. And this one is going to be phrase output. So, common phrases didn't work. Well, they both didn't work because I forgot .text. Oh, well, the second one, I would have created a file without a file extension had I got that far. But if you want to see where I went down on this in file open. Okay. Well, let's do it the right way this time. Okay. So we're going to run it. Make it big again so you can see it. Common phrases .text and phrase output .text. Okay, so common phrases .text. I misspelled it. My. Well, you'll do this too, right? At least I hope you will. One more time. Common phrases .text. Phrase output .text. Processing complete. So let's look at phrase output. No? Just what we wanted. Okay? Just what we wanted. Now, interesting to see what we got. How many lines did we got? Well, we got 6 lines, right? Plus, we have a 7th line without any content on it. Why? Because of that last new line character that's there. That last new line character looks like a 7th line without any input on it at all. Okay? Interesting. That's just what we wanted. Okay, so I just want to point out that what we have here is the pattern, the batch processing pattern. So what do we want to do? Well, we want to take the algorithm that we had before, the one that took the input and it changed it around, and we're going to plunk it right in the middle of the processing loop. All right? Let's do that. So where was we? Where were we? So we're on 13. The one before here was 4 and 9. And 4 and 9 is where we got this input phrase. And we printed this. So I think what we need, sorry, got to make it bigger so you can see it. Okay, we're not going to have to prompt for it, right? So we don't want that. We want to start with maybe 15. Okay. Are we going to have to print it? No, we already got printing code. Okay. We're just going to do the transformation here. So I'm thinking that what we want is we want to start with line 14. And we want to end with line 21. And we want to copy it. And we want to plunk it right into this area here. Okay. Now, I don't know how I got the input phrase, but I seem to have gotten the input phrase when I didn't want the input phrase. So I got the first line when I didn't want it. Okay. And oh, let me back up. So I've got the 4 and I've got that print. Now let's go back and try to do it again. Oh, I did ask for too much. I don't want the input phrase. So let's copy right here. Let's start at words. Well, let's end at the edge here. That might actually paste a little better. So we're going to go in here and let's just go right here. We're indented. Let's give it a paste. Well, wasn't exactly what I wanted, but I think it's okay. So got this. Give that a tab. We've got these two. All right. I'm sorry. So for line in, so we want to, what we're getting in is called line. Okay, so for line in, no, wrong. Let's just this. Let's just do this easy way. Let's say input phrase is going to come from line. Okay, could we have done a little bit of extra work there? Yeah, that's fine. Okay, so input phrase is line. We want to split the input phrase into words. We want an blank output list. Now we want a for loop. Okay, on what level do we want the for loop? Well, we want a for loop within a for loop. Okay, we have the for loop that is making the batch thing go. Okay, and here we want a for loop that's going to it's going to make the reordering go. So I'll get rid of that. Okay, and then bring this down here. Okay, and what do? Well, when we were done with that code, it was an output string. Okay, so instead of line, let's use output string. That looks pretty good to me. All right, so what we really did is that we took our algorithm, our transformation of a line of text, and we just sewed it into the pattern. We had a shell that we based upon the batch processing pattern, and we just opened up a place for the work to be done. We took some code out of another program, okay, and then we made sure that the names that we had connected to our shell. All right, then this should work. So let's give this a run. All right. And this is called common phrases. .text. And the output is called phrase output.text. And let's run it. Processing complete. Let's look at phrase output. Hey. We're close. Interestingly, though, we've got a little bit of a problem. We've got 3 blind mice is not exactly what we thought we were getting. Okay, we're missing the last character. How's all this happening? Oh, well, I'll tell you what's happening here. When we split it, we get rid of our problem of having one too many characters. So let's us go back and adjust the algorithm. Okay? All right. So it looks to me like we probably just want to print out output string now. See how it goes. I don't think we're going to have a carriage return on the output string. So look at that, because we're not just taking the input line. All right, and then I think we have a problem on the input side too, but let's undouble click it to go back to the regular size. Let's run it again. Okay, common phrases dot text, phrase output dot text, runs to completion. Now I think we're going to be close, but not there. Three blind mice works. How now, brown cow. We love Python. I am a data scientist. Librarians are the warriors of learning, and only a small fraction of this mass will end up in the archive. Well, those all work fine. Okay, so no problem at all. That's exactly what we wanted. So let's just take a peek here. I think it's in pretty good shape. We got 2 lines up here. We've got 2 lines down here. Do I leave in the comments? Well, the comments are pretty intentional. Okay, so just because this is kind of the first time that we're doing this one together, I'm going to leave them in there. Okay, and let's go up to the code and inspect it. Inspect code. Just the current file. No suspicious code found. Very nice. So we're all done. We've already tested it at its current phase, so everything's good. Very nice. So that's number 13. I'm going to move on to number 14 in just a moment. Okay, we're going to move on to number 14. And number 14, it says this, word count. Apparently that's a sentence now. A common utility on Unix, Linux systems is a small program called WC, which is short for word count. This program analyzes a file to determine the number of lines, words, and characters contained therein. Write your own version of WC. The program should accept the file name as input and then print 3 numbers showing the count of lines, the words, and the characters in the file. So the count of the lines, the count of the words, and the count of the characters. Okay, well, that sounds interesting. How are we going to do that? Well, let's think about the pattern for this. Okay, so think about the pattern for this. We'll take a pause here a second, and then I'll show you what I think the pattern is. Okay, you're back. So here's what I think the pattern is. I think this is the kind of thing where we're doing a text analytics. I call this it's funny, things that you do yourself rather than use some software that was created for that. I usually refer to it's like you're coming up with a recipe yourself and you're creating it. So I call it Betty Crocker whatever. So this is Betty Crocker Text Analytics. If you're doing text analytics, you're probably using a software library like the one from Stanford, the NLP one, right? But to get the idea, you got to be able to do this stuff yourself. So this is Betty Crocker Text Analytics, okay? And for this kind of text analytics, you do well to just get the entire file in and put it into a single character string. So I see the pattern is read a file into a single character string, analyze the text in the character string, print statistics. Okay, so you're going to do the word count thing. Okay, but I'm going to do something different. I'm going to use a pretty big file. I'm going to use the text of Moby Dick that I got from Project Gutenberg. Okay, I'm going to read it into a single character string, and then I'm going to analyze it. I'm going to count the frequency of the string whale. I'm going to count the lines, and I'm going to find the starting position of the last occurrence of the word captain. How does that sound? And I'm going to report the results. I think I need another R in occurrence. Spelling. Oh, you know what? It doesn't seem to want to correct it. It just wants to complain about it. Isn't that nice? I'm sure that there's a function key to correct it. Okay, let's get started. First of all, let's look at the input data. I have a file mobydick.txt. Okay, and this is a text file. And where did I get it? I got it from the Gutenberg project. There's some front matter here that it guides you to where that project is, and you typically can get a plain text version of anything. Okay, the only problem with text this large is it's hard to do good testing, right? I picked it because it would be fun to see what the answers would be in Moby Dick. Okay, but to do good testing, you have to know what the right answers are to make sure that you got the right answers. So probably this would not be the best testing file. I probably should have a testing file that's pretty small. I should make sure that I get the right values, and then once I get that to work, then I probably ought to run it through, run it with Moby Dick to get the satisfaction of the large file processing. Okay, but I'm working without a net here, and I'm not saying that you should do it. I'm just saying that I'm doing it. Okay. Here we go. So that's the input. Okay, let's go back to the tutorial. What do we need? Well, we need the standard stuff, right? We need to define main. I know this seems to get old after a while. Well, let's just put a print in the beginning for the heck of it, so it's not going to complain about our call to main. Okay, here's our call to main. That's good. That's all done. Okay. And let's see. We're going to print some character strings up front. And what do we have? We have 3 lines here, so I'm going to clone them. Well, wouldn't think it would do that, but it did. Okay, so I'm just going to copy these. And this one. And the last one. And you remember I want a blank line after I print out my little polite description. So again, I'm just going to do the \n on my last line. So I'll get a blank line after it. Okay, and I'm going to capitalize the first letter of these sentences. Just because I was lazy before doesn't mean that my users have to see that. I'm only sharing that with you. Okay. So let's give that a look-see. Let's give it a run. And that's it. one of the nice things about putting the print up here is you've got something to test before you've even done anything wrong. Okay. So read a file into a single character string. Analyze the text in the character string and print statistics. Okay. Let's get started. So, what do we need to do? Well, we need to, ideally, if you want to have a useful program, you don't want one that only works on one file. So the thing to do is to prompt the user, ask for the file name. Now, there's probably a more robust way to do that where you prompt for the file name, then you check it out, and then if there's an error, you reprompt. Well, we just don't have all the equipment for that yet. Okay, so let's say file name. Let's call this in file name. Okay. Sorry. In file name equals. Again, we're going to input. Please enter input file name. Colon space. Okay. All right. I'm not going to test that because we've done that so many times. I think I can get a little bit further along. Okay. Now what I'm going to do, well, as soon as I get that, I want to open it. All right. Do I have to open an output file? Well, no, this isn't your standard batch approach because we're just going to read in, we're going to read from a file on the input side. Okay. But we're just going to print to the console. So we only have to define one file. We only have to open one. So let's do this. Let's create a variable to hold the file object reference in file equals open. That's a method. Sorry, that's a function. Open in file name, comma, mode, R. Okay. Okay. And now what are we going to do? Well, we're going to read. Okay. So let's say, let's call this the corpus. Corpus. This is all of our text. It's all one big text. Equals in file read. So if we do a single read, it's going to suck the entire file in as a string. Wow. Okay. So then let's see if we can print it to the console. What are we printing? Do we have to iterate over it? Turns out we don't. Okay. It's a text file that's already formatted for printing. How so? Well, it's got new line characters in it. So if we just print out, if we just take this entire, this variable name corpus, and we print that, it's going to include all the new lines that we need to print it out on the console with all the line breaks that we need. So let's just do it. Let's just say print corpus. That looks pretty good. Let's give that a read. So what's it called? moby_dict.txt. All right, we'll give that a run. Run. Make that a little bigger. moby_dict.txt. Wow. So why didn't I do something like a processing finished here. I didn't because it's creating obvious output, right? The problem is when you're doing that batch approach, if all the output's going to a file and there's no behavior on the console, how are you going to know when you're done? Okay. Now, here we get this process finished with blah, 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 but it's usually polite to have a message that says, we're done. In fact, what some people do is while they're in the processing loop, they'll print out something like a period space or something like that when they're going through a batch processing loop. So you can see these dots appear as we go through. So you can see that we're making progress and the whole thing hasn't bogged down. But we're not going to try to show progress or that kind of stuff. But here, this output is enough. Let's double click on that tab. Isn't that nice? Oh, of course, that's already the whole thing. Let's see. Ah, there it is. I double click on the gray space there. That's how I get it. This looks pretty much like my, let's make that a little smaller. This looks like the Gutenberg thing altogether. Yeah, that looks good. Now, there's a lot of text here. One of the things that I wanted to show you was, we talk about memory being a limited resource. So you go, well, can I take a book and can I bring it into, can I bring it into a character string? Well, works for Moby Dick. It'd probably work for War and Peace. It'd probably work for the Talmud. It'd probably work for some, books that we know. As big as they are, they're only typically 1 byte per character, and there's a lot of memory. At least on my computer, there's a lot of memory, so no problem at all. Sooner or later, though, you might run out of room. What would that look like? Well, it would blow up, just like we see things blow up all the time. Okay, let's go up to that gray bar and double click again, and that goes back in place. Now, have we done everything we need? No, I just want to point out we haven't done any cleanup. We haven't closed the in file. Is that a horrible offense? Well, it's not good citizenship. In these kind of programs that we're running, they run by themselves. And so if you forget to close an input file, well, then you leave a bunch of resources stranded. Well, that's okay because the program ends and now they're not stranded anymore. In some kind of a web serving environment, this kind of thing would be a problem. Even with an input file, you would always want to make sure with all these things that you create, input file objects, HTTP connections over the web, you'd always want to make sure that you close them and release the resources, because pretty typically web serving environments run for a long time, and if you accidentally don't close up all this stuff, you begin to leak memory. And this is not something that we want to do. So for a lot of reasons, although typically even in a lot of Python web serving environments, that would not even be the biggest of problems, would not really cause a memory leak. But let's just do it because we're good citizens, okay? So let's say in file, close. Okay. Sorry, in file dot close, paren. That's what we wanted to say. Okay. And let's give that a run. Just make sure we haven't introduced any problems. Okay. And it's going to be Moby Dick. Text. All right, that looks good. It hasn't created a problem. All right, so let's look up here and see what we do. Well, we didn't claim we were just going to print the whole thing out. Geez, now that we know how to do that, anybody can do that. So we don't want this print corpus anymore. Okay. And also, I want to point out that we could let's back up. You know that print corpus? Let's get that line. I want to make sure that you know that we don't have to keep that file open in order to print. Okay, so we could close that file, okay, and then print. It would work fine. Why? Because the content's already in the character string object corpus. Okay, so we can close the file. We're not referring to it again. All right, let's give that a test. Just want to demonstrate that. Moby Dick text. Yeah, that worked fine. All right, so probably we ought to close this while we know it. Okay, and then let's just I'm just going to take those, and this is all the file stuff. I'm just going to put all that input related stuff all together. And here's the output stuff. Okay, so we don't want to print it anymore. What do we want to do? Well, we wanted to get the frequency of the character string whale. How many times do we get whale? Okay, so let's look at that. So we want to get a count. So let's call it count whale equals corpus, and let's call the method count, and let's say that the substring is going to be whale. Okay, and then let's print for right now. Let's just print count whale. Okay, let's not be too nice. All right, let's give it a run. Make it a little bigger so you can see. Moby Dick text. Whale occurs 1,331 times. Now, again, do as I say, not as I do. Don't have your testing. These kind of initial tests are called unit tests, where you're going to test your unit of code. Don't do your unit testing on a large corpus like this. Okay, you would want to create a manageable size file. Maybe take a paragraph out of this, and well, I could do that, couldn't I? So I could go to Moby Dick, find a paragraph. If I'm going to preach this, I ought to do it. Let's see if we can find whale. Not waddle. Whale. Let's find a big paragraph that's got a couple of whales in it. Alright, here's a block of text where I could actually go through and count this. So it looks like whale occurs 1, 2, 3, 4 times. Now I want to point out that when I do this match here, I am matching capital W whale and small w whale. Okay, so we've got these. So let's copy this. And let's open a new file. And let's call it test moby.txt. And let's plunk that paragraph into it. Okay, and make sure that gets saved. And we could probably count these up by hand. So let's see, 1 whale, 2 whales, 3 whales, 4 whales. Whaling isn't a whale. We've got 4. Let's see, 4 or 5. Okay. Well, we could do again. We could do a find, which is a control or a command F for whale. 1, 2, 3, 4. 3 of them are capitalized. 1's lower. So how many are we going to find in test Moby? Think about that. Are we going to find 4 or are we going to find 1? Interesting. Let's go back to our thing here, the old thing, and let's give it a run. This time we're going to give it test Moby. .text. 1. We only found 1. Why? Well, because count looks for this exact character string. It's case sensitive. Now, you would go, oh, I wonder if there's a case insensitive count. Well, not that I see. Okay. So, how could we do this? Well, let's say this. We have count whale equals that. And then we could say count whale. No. Sorry. Let's clone this one, because this is going to be an interesting trick. But let's clone this one. Count whale plus equals, right? We're going to add to what's already there. We're going to ask for capital W, right? That looks good. Let's give that a run. So Moby test dot text. Okay, what was it called? Test Moby. Test Moby. Text. 4. Now, that's right. How do I know that? Well, because I can look at that editor and see what's actually there. Could I have done that with the full corpus? No, not too well. Okay? I'd be working against myself. See, once something, when you're testing, you want data that's realistic but manageable to count the answers by hand, so that you know in your testing that you're really doing the right thing. Okay, so that was the first requirement. I think we've got that. Okay, so let's see. We want to calculate the frequency of a string whale. That's the number of occurrences. Count the lines. Okay. Okay. Let's give that a try. Okay. Let's count the lines. Now I'm going to show you a couple ways to do this. Okay. So let's get a variable for it. Oh, sorry. Before we do change it, let's pretty up what we said. We can say whale the word whale, yeah, whale occurs whale occurs. Wow, let's just do that. And then we'll do this. And then get rid of the extra, I'm sorry, comma, count well. Okay? All right, so run that again, just to prove that we haven't broken anything. Test Moby. Text. Will occurs 4. Okay. Now, what's the next thing that we want? Well, we want the number of lines. Let's do that. So let's say count lines equals corpus count. Is there something that we can count there? I think we can count the new line characters. Okay, they're not really characters in the true sense because he can't see them. They're more action-oriented data. But let's see what happens there. So then let's say print. That wasn't what we wanted. Let's just get this whole line. Copy. Let's print that. Will occurs. We'll just say lines in file. Okay. Count will? No. Count lines. Lines in file and count lines. All right. Let's give it a run. Now do we know how many lines we think we're going to get? I think we're going to be close to whatever it says. Here it says there are 9 lines. Okay? So I want it to match this. Okay? So I think we're going to be within 1. So let's look. Time to test. Give it a test. Test Moby. Text. 8. Why is that? Well, because we have 8 lines that end in a new line. Okay? Now, how do you want to count them? Well, this text editor counted them as one more line. Okay? It says, oh, we have a start of a 9th line. So let's for it grins here, let's say count lines plus equal 1. Let's bump it up by 1 so it's going to be equal. Okay? Now, this is always a discrepancy between counting lines and looking at what's in the text editor. So you really have to ask yourself how you want to count them. All right? I just decided I want to match the results I get from the text editor. So I'm going to run it again. I'm hoping to get a 9. So test Moby. .text. I got a 9. Oh, and I say line is file. Boy, I can. So that's lines in file. Now, am I going to run another test for that? No, I pretty well know that I've got that fixed. I'll check it the next time through. And we've got something else we want to do. We want to find the last occurrence of the string captain. We want to find the starting position, the index. Okay? Okay. Well, Let's think of that. We want the starting position of the last occurrence of the word captain. Wow. Let's get working on that. Let's start by making it real easy. Let's add the word captain right here and make sure that we can find it. Okay? Now, come back. So, how can we find the word captain in the corpus? Well, we can find it if we use find. We would be finding the first one. Okay, let's try the first one. So let's say position captain. Okay, equals corpus find captain. Okay, how's that look? It looks fine. And we're going to need a print. We need some blank lines too. We're using up all our blank lines. Okay. Now let's print. So let's try to have it look like this. Lines in file. Position last captain equals position captain. Position captain. Okay, good. Let's give this a run and see what we got. So we're going to run it again. Make this a little bigger. Say test Moby. Text. Position of last captain is 0. Now, do we want it to be the index or the position? Well, let's do this. Let's not make a lot of work for us of having to add one, because the index is always going to be one less than the character position. Let's change what we're looking for. Let's call it the index of captain. Oh, sorry. Let's refactor, rename index. Wow, we don't like that. Sorry guys, this is going completely berserk. Yeah, you don't want to do that. Sorry. I have no idea what I've done here. This is whole thing gone kaflooey. Okay. Position last captain. Well, we'll fix this. I fix it manually. Index. Last captain. Okay, equals corpus find captain. Index last captain. And then we're going to print index last captain. Index last captain. Alright. So, if we run this again, we're going to say 0, and that's going to be pretty much right. Okay? So, we got this. Test Moby. text. Test.mobi. That's not going to work. So that's the last thing you try. Test_mobi. Index last captain 0. Well, that's just where we think it is, right? Because if it's the first one here, that's it. Okay. So let's put the word captain down here. Okay. And let's see if it does what we want. I'm going to tell you that it's not, but let's see. So Mobi, no, test Mobi, text. Okay, 0. Oh, that's not the last one though. That's the first one. Right. That's because instead of find, we need rFind. Find from the right side. So let's do rFind. Okay. And let's see what we get. Give it a run. Make it big. Test Mobi.text. 496. Well, that's probably right, but I'm not going to trust for testing that it's right. So how am I going to do this? Well, I know it's good at finding the last one. Okay? Well, how can I figure this out? Well, let's just do this. Let's go back to the test data. We've got the last one taken care of. And let's just, let's get rid of the last ones. Now the first and the last one are the same. Okay. And then let's put 0, 1, 2 there. So indexes 0, 1, 2 are the right value, are the indexes of each of those characters. So the index of captain, which is the last caption, should be 3. All right. Well, make sure that's saved. Let's give that a run and see what we get. Okay, so let's run. Okay, and test Mobi.text 3. So it says that the index is 3, and I think that we have that exactly. Yeah, the first one 0, 1, 2, and then captain starts in 3. Okay, but now if we put captain to employee, we'll just put captain in here. Okay, that's fine. Then we ought to get another number, right? So let's give that another run. Let's give it a run and make it a little bigger. Test Mobi text. Okay, so now we've unit tested the program. Okay, we've tested it with test data. We're pretty sure that we've exercised it. We've found where it could have been making errors. Okay, we were able to hand count the wells. We were able to count the lines with a text editor, and we were able to use the text editor to do the testing and the positioning for captain. So that looks great. Oh, you know what? That almost got past me. I misspelled captain. I spelled it Captain, and it hadn't actually changed. So was that properly tested? No. That's because your natural inclination is to think the test passed. Okay, let's run this again. Make sure that's saved. The Control S. Okay. So test moby.text 240. That's probably about where that captain is, right there. Okay, well, now I've got my test to work. Now, do I need to pretty up the program anymore before I do my final test? Because I want to make sure that my final test is on. I'm going to do it on the real Moby Dick, but I want to make sure that I've got the program in the shape that I'd like to have it in. Okay, and the only thing I can think of I need to do is to inspect the code. So let's inspect it. Current file, that's good. Okay. So what does it say? Typoed in the word Moby. Oh, so the spell check doesn't like that because it's not a capital letter. Well, that's okay. I could say save to dictionary, but I'm not going to. All right, that's fine. I don't have any worries there. And let's do a final run. So let's run, and let's run it again. So sorry, run it, and let's have it be Moby _dick.text. And will occurs 1,695 times. Lines in the file 22,660. The last index of captain is way up there. So let's see, 3. It looks like 1,215,181. So that's the index of the last instance of captain. Pretty cool, huh? So again, the idea here, I mean, there's a lot of ways to do text analytics, and one of the easy ways is just to put this into into one variable and to figure it out from there. Okay, and that's the one that we're going to take. I just want to point out that when we counted the lines, we counted the characters. Another thing that we could have done is we could have split corpus on into lines on the new line character, and then we could have counted the lines. Okay. So in fact, that's sort of an interesting way to do it, and maybe a little more. Of course, it's a lot more processing to do it that way. But and how could we have counted the lines? Well, we could have used the len function and passed it the list that we got when we split corpus, and we would have found out the length, and that would have been the number of lines that we had. So that's the kind of maybe more elegant way to do it. I don't think we would have to add a +1 then. I think we would have been fine, because when you think about it, when we're splitting on the new line, well, then we're going to split on the last one, and we're going to create that last line. So I think we're probably going to be okay. I'd have to worry about that later. But there you go. So that's it. That's all of the tutorials for this week. I wish you luck. I'm around to help. See you later. Bye-bye.